Okay, so today we're going to get into applications of linear equations. So this is where they become real life focused. So with the first one, the situation is you need to budget for next month's bills. So you start by examining your Wi-Fi plan. There's a $5 access fee and $2 per gigabyte of data that you use. Write and graph a linear equation to represent the total cost of Wi-Fi based on the amount of data that you may use. So the linear equation is going to represent the total cost. So that's what y is going to tell us, is the total cost. Based on the amount of data used. So in this case, we have a $5 flat access fee. So it's going to cost $5. And then anytime you see the word per, that's usually going to be your slope, if they give you a problem with the slope in it. So $2 per gigabyte. So we're going to have plus $2 times every gigabyte of data that we use. And then this is technically in slope-intercept form, but we can get some points as well. So an amount of gigabytes that maybe you would use in a month, maybe 5 gigabytes. So we can plug that in then. So 2 times 5 is 10, plus 5 is 15. Maybe you're going to use 10 gigabytes in a month. So 5 plus 20 is 25. And maybe you would use, I don't know, let's say, we'll just go up to 15. So maybe 15 gigabytes in a month, and you would have $35. So if you use 5 gigabytes of data, you'd have $15, 10 gigabytes of data, $25, and 15 gigabytes would be $35. Make sure you label your axes then. So these are the gigabytes of data used. And then this is the y-axis is gonna be the dependent variable, which is your cost. And that's in dollars. So let's go by fives. For our gigabytes of data used. And then for our y-axis, we'll go by fives as well. And then we can plot our points, and we have our graph. So 5 is at 15. 10 would be at 25. And 15 would be at 35. So our line is going to look like this. All right, the next one is a pretty similar situation. So I'm going to leave this one for you guys to figure out. You should be able to define your variables. So x and y, based on what this question is asking for, which is here. Whoops. So this is going to tell you, or give you the information to define your variables as x and y. And then you're going to write an equation in slope-intercept form. You're going to get some points, and then you're going to graph it. Okay, the next situation, however, is a little bit different. So you want to get t-shirts for a group of your friends. You know that 10 t-shirts cost $48. And you also know that 15 t-shirts cost $63. So we want to write and graph linear equation to represent the total cost. Again, we're going to look here for our variables. So we want the total cost. That's going to be y. And then what it's based on is going to be our dependent variable, our x. So based on the number of t-shirts that you buy. Okay, so in this situation, we're not given a flat fee plus an amount per t-shirt. We actually have to find that. So we have 2 points, and we know that 10 t-shirts cost $48, and we know that 15 t-shirts cost $63. So we've been working with writing linear equations. When we have 2 points, we need to first find the slope of that line. So it's going to be 63 minus 48 divided by 15 minus 10. So 63 minus 48 is 15. And then 15 minus 10 is 5. And 15 divided by 5 is going to be 3. So the slope of our line is 3. Now we can use either method to figure out the equation. So I'm going to use point slope form. And again, we can use either point. So I'm going to use 10, 48, and I'm going to use a slope of 3. So y minus 48 equals 3 times x minus 10. So if we distribute the 3, y minus 48 equals 3x minus 30. And then if we add 48 to both sides, then y is going to equal 3x plus 18. So our equation then in slope-intercept form is y equals 3x plus 18. So we can get our points then. This one's kind of nice because we have 2 points to use, so why not use them? So we have 10, 48. We don't have to do any math then. And we have 15, 63. And maybe let's go 20. So we'd have to add another $15 to that. So 20 times 3 plus 16. 20 times 3 is 60. Sorry, plus 18 is going to give us $78. Okay, so our x-axis is going to be the number of t-shirts. And then y is going to be the cost. Again, this is in dollars. So we'll go by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, so on and so forth. And then for the total cost, let's go by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, so on and so forth. So we have a point at 1048, which would be right about there. And a point at 1563. 20, 30, 40, 50, 60. Which would be about there. And then 20 is at 78. Or 10, 20, 30, 40, 50, 60, 78. Which would be right about there. And that's going to give us a graph for our line. It's going to look something like that. And you can see then that our y-intercept would be about 18 as well. Okay, so the car value is going to be very, very similar. The average value of a 1999 or a 1991 Mustang was $15,230 in that year. In 1995, the average value was $10,000. Let y be the average value of the automobile in year X, where X equals 0 represents 1991. So in this case, we want to write and graph a linear equation that represents the value of the automobile. So y is going to be the value of the automobile. And X is going to be the year since 1991. And then you can come up with your equation. So the points then that you'll use for this one, so 1991 is year 0. So we have a point at 0, 15,230. And then in 1995, that's going to be 92, 93, 94, 95. So it's going to be 4 years later. From 1991, and we know that the value is $10,000. So these are the points that we're going to use. So we have to first find the slope. So figure out what that's going to be. And then you actually have your y-intercept right here. So your y-intercept is the starting value, which is 15,230. So once you have that, you can figure out some x's and y's. So we have 0 and we have 4. So why not do 2 as well? And again, we know this is 15,230. And then for 4, we have 10,000. So you could probably make your x-axis go by 1,000s if you wanted to. Or sorry, your y-axis. 1, 2, 3, 4, 9, 10, 11. We only have 12. So I would say make this go by 2,000. So 2,000, 4,000, 6, 8, 10, 12, 14, 16, 18,000. And then just make this go by 1s. So finish that out and then submit your notes, and that's your assignment for today.